Alright, we'll start now. We'll start now. Now, before I go on to page 46, any question from 44? Are you sure?
I think that's what we know.
Yes. And double check that.
The calculator gave up.
You know that feeling.
The guy goes like, I don't even.
Okay, so before we go on to 46, is there anything from 44?
Of course there is.
Yes, so that's what I'm waiting for. So what do we need to see from 44?
The you can also try question.
Which
No.
one?
It's,
Oh, yes, that one.
I just want to check for a. Is it?
Yeah, the one you could try question,
I
yes.
can try questions.
Do you want?
Oh yeah, the A1, yeah.
Hang on, this
So use some of your magic.
yeah.
Do some mana, I guess.
MP too low. We'll have to do. Okay, do you want to see 4A?
I want to be first.
Hey, come on, focus now.
Yeah. Yes, for a.
4A. 4A? Yeah? Okay, so 4A first. So I tell you that Px plus Q power 6 equals 1 plus 6x plus 15x squared, etc. Okay, so here we're looking for the P and the Q. So what we need to do is expand on the left first. Okay, so on the left we get, oh, by the way, is this ascending or descending for x?
Ascending.
Ascending. So what I'll do is I'll just write down the Px and the Q. Px, Q, Px, Q, and then Px, Q, and of course there's more. So do I want to start at power 6 or power 0 on the x? 6 or 0?
0.
Yeah, why 0?
Because it's just a thing.
Yeah, so this is 0, and then the Q would be 6. This is 1, 5, and then this one here is 2, 4, etc. And then in the front, well, this one here is 6C0, 6C1, 6C2.
So for me, you give the PS.
Get which?
PS.
Oh, that's this piece here. I'm
So
expanding.
it's the X and the Q is
Yeah, is the Y, yeah. Alright, so here I'll end up with Q power 6. Here I'll get 6P Q5X. What's 6C2? Is that 10? 6C2? What is it? 15? 15 P squared Q4 X squared. Okay. Now what you do is you compare it. So this piece here, what must that be the same as? Yeah, 1. And then this piece here is 6. And then this piece here is 15. So I get, let's start with the first one. Q power 6 must equal 1. So what does that mean Q must be? Yeah, Q must be 1. Okay, I can put that into the next one. 6P Q5, what must that equal? 6. But what's Q? 1. 1 power 5 is 1. 1 times 6, still 6. So I get 6P equals 6, so then P equals, in this case it's also 1. And then you should use the last one to check if your answer is right. So you can put P and Q into the last one. So you get 15, 1 squared, 1 power 4. What does that equal? 15,
Yeah.
which it should. So the answer is P is 1 and Q is 1. Now, sometimes, in fact, like in the first one, it's not only 1. It could be plus or minus 1. Okay? So here you have a plus or minus choice. I correctly chose plus. Hurry up, guys, come on. I correctly chose plus. But the way I know that it was right is because I did get the correct answer for the third one. Yeah? Say again?
Would it be
Oh, it'd still be the same, wouldn't it? Oh, okay, so then you really have two choices here. But I think the question might...
The one with the odd power.
if it's power 5, for example? Is
That would be minus
If it was power 5, yeah. So I guess I have two possible answers here, but I see now in the question, I fixed this by saying in the question, P and Q are positive. So I really had no choice, actually. But you're right, yeah. It didn't actually matter here because you square it. Okay. Will you get something as difficult as this in the exam? Maybe, but from that page 44, this question is the most difficult one. Hurry up. Joshua, not the first time you're coming in late, is it? Is it? No, I don't think so. Hurry up and sit down. Okay, so as I was saying, probably 4A is as difficult as it would get in the exam.
So,
Yeah,
you re-explain it.
it's recorded. Yeah, no, I just need to go on to the next one.
Can I ask you
Yes.
one more? In 3H, after you get like the answers,
Yeah,
how do you combine both to get to your final ascending or descending answer?
in 3H, 3H,
Or 3P, sorry.
3P, yeah.
Yeah.
You have to do each of the two as ascending,
Yeah, I've done that.
and then you multiply them together.
The whole thing.
No. Remember when we did an example last time? I didn't need to look at every possible multiplication. Do you remember that? So for example, can everyone have a look at 4 or 3p? What's the biggest power of x you can make when you multiply those?
4.
Ah no, there'd be one bigger. 8, yeah, x power 8. How would you get an x power 8 in that question?
Yeah, the x.
Yeah, the x4 multiply x4. So if I want 3 terms ascending, oh, it goes up to x8. Yeah, so actually you should look at the smallest one you can make. What's the smallest one you can make? Yeah, no x, isn't it? How would you get no x? What would you be multiplying for no x?
First two, because they don't have an answer.
Yeah, the 2 and the 1. So if I want ascending, I would have no x, x, and x squared. So the ascending one is a little bit easier. I need to go on, but just keep in mind that the last lesson was on Moodle, and there's actually another video on Moodle because with another class last year, I did an extra hour on this. Okay, but I can't do an extra hour with this group because we passed our tutorial already. It was on Monday. And the next tutorial's not till after the break. So anyway, there is actually 2 videos on this lesson on Moodle. The one I did for you, and then a lesson called Revision of this, I think. Yeah. So there's 2 videos, okay? And in the second video, I think I do more examples of that one there. So you should check, you should have a look at it, okay? All right, we're going to go on now to 46. Okay, so now Sequence and series is the name of the chapter, but it's only in this lesson now that we actually start to look at a sequence. Does anyone want to try and give me the definition of sequence, or do you know what a sequence is? It's a pattern, good, yeah. Pattern of numbers, yeah.
4, 8.
Yeah. These are great examples, but give me a sentence.
But we don't do alphabet in math though.
No one wants to try and give me a sentence. Yeah, pattern of numbers, yeah. Joshua? Yeah, we all have the right idea. There's just two key words that you're missing there. Yeah. Yes, close. Yeah, that'll do. Yeah, logical. That's not the word I was thinking of, but it would do. Yeah. So you have a pattern of numbers, but importantly, it must be an ordered pattern of numbers. So what I mean by that is there's a first, there's a second, there's a third, there's a fourth. That there's an order. That you can't just swap them around. And as you've said, Joshua, there's a logical pattern. In other words, there's some rule that tells you what the next one is. So, an ordered list of numbers that obey a rule. So, the saying you gave me some 2, 4, 6, 8. So the rule here, what am I doing each time? Adding 2. Yeah. And please note, this is a different sequence to this. 4, 2, 8, 6, etc. Although they're the same numbers, we say they're different because they're in a different order. So the order does matter. Okay? So it must be ordered and it must have a clear rule. So let's just have a look at some examples. We try and figure out what the order is. So, for example, no, although there are special types we'll look at that have equations, but it's not, there's not like one formula for all the different possibilities. Okay, so -1, 1, 4, 8, 13, 19. Okay, I would like to know, in this example, it's the first one there, what number comes next. So if you look at this, what happens as I move from -1 to 1? What have I done? I add 2. And then from 1 to 4? No, add 3. And then 4 to 8? Add 4. Add 5, yeah. Add 6, so therefore add 7, so that should be 26. Yeah. Okay, can I scroll down? Okay, so that's not too bad. Now, next one. -1, -3, -9. Well, I won't write them all down there. I know better. -9, -27, -81, -243. Okay, what have I done here? Yeah, I've multiplied by 3, and here 3. So it's clear what's happening. I'm multiplying by 3. So the next one will be -243 multiplied by 3. What's that? 9. 7 to 9, is it? Yeah. And minus, yeah. Okay, now I'll give you one to try. Let's see. Can everybody try P for me there? And then we'll go to the next one. So have a try of P. Okay. Does anyone have the answer? Yeah? Yeah, what do you think it is? Yeah, and what's the rule? Yeah, you multiplied by firstly 3, and then you multiply by 4, then you multiply by 5, multiply 6, multiply 7, and then multiply 8. Yeah. Yeah. This is flashing a lot. Okay. That's good. That's good. All right. Now, this isn't the best way to do these. You want to actually write down a formula. Okay? So, how can we write down formulas for sequence? So, this is how we do it. If I have a sequence, I call the first part U1, the next term U2, U3, U4, etc. So we have formula UN. Yeah. Guys, someone turn their music off. Don't be stupid. I can hear it playing. Thank you. No, come back at 10. Guess who that was? Yeah. Okay, so let's take an example here, the first one. If I write down UN plus 4 plus 7n as an example, this is a formula that makes the sequence. What you do is to get the first piece, you make n equals 1. So if I put n equals 1 in there, what do I get? U1 equals 4 plus 7, which is 11. Then if I want the next one, I put in 2. So what would I get here? 4 plus 14, 18, and so on. So, that's just a general formula. So you get this in the exam sometimes. They might give you a formula and they might ask you to make the first, second, or third term. Although that doesn't really happen. What usually happens in the exam is they give you these numbers here and they ask you for the formula. Let's maybe try and do an example. I'll go back down. But if you take the first one you did for me, this one here, we can try and make a formula for that. So I should have UN equals. So what number do I start with? Minus 1. And then what am I doing each time? I'm adding 3, isn't it? So I do plus 3. But I don't write n here. I should write n minus 1. And the reason for that is because when the term is the first term, what's n? N is 1. So I don't want to add 3 for my first term. I only want to add it afterwards. Can you see that? No. If I put n equals 1, what does this become? 0. 0 multiply 3? 0. So what am I left with? Minus 1. So I want minus 1, don't I, for my first term? And then when I go to my second term, n is 2. 2 minus 1? 1 times 3? 3. So then I add 3, and what do I get? I get 1. Minus 1 plus 3.
What's the rule, sir?
No, we'll look at the rules more in the next class. I'm just saying that, as an example, you figured out the rule in your head. You add 3 each time. So we're just looking at the idea that you can write that down as a formula. Okay?
Can you give us another example, please?
Yeah, no, just really quickly. The next one here. 1 second. The next one. What number do I start with? Minus 1. And then what do I multiply it by? Multiply by 3. But I don't write power n here. I should write n minus 1 because I don't want to multiply by 3 at the start. Now don't worry. These get an entire lesson. Okay? There's a whole lesson on doing this. I'm just doing this as a little example so you can see what will happen later. Yeah?
But the question said we use this formula. Can we still solve the question like how we solved the first two without using the formula?
For which one now?
Like,
Oh, in the first one, do you need to use the formula?
like if if they ask us to use the formula, can we still solve it without using the formula?
No, you should use the formula, but this is something that will come up in a later class, so we don't need to worry about it just yet, okay? So, you can see in number 2, I just want the first 3 terms, and I did 2a for you. So can you tell me the first 3 terms for 2b? Okay, look at 2b. So what are the first 3 terms in that sequence? Vn equals 8 times minus 7 power n. So I want the first, the second, and the third term. So what's the first term? Yeah, minus 56. The second term? 392. And then the third term? Minus 2744. Okay? Right. Now, next, if we look at 3 then. So, it's basically the same idea, except I tell you which term I want. So for example, 3b, I tell you that Vn equals 2 plus 6n, and I want the 7th term, V7. So what do? I put n equal to 7. So what do we get? V7 equals 2 plus... Yeah, just give me the final answer then. 2 plus 6 times 7? 44. Now, this is just called, general formula. But there's actually 2 types of general formulas. So this idea is we're using a general formula to get each term of the sequence, okay? But, like I said, there are 2 types of general formulas. This one, you might call it a direct. And the reason I say direct is you do it directly. You want a term, like the 7th term, you put 7 into the formula and you get your answer. So it's very direct. Okay. The next type of formula is something that maybe a lot of people haven't seen before. Okay, so you need to really listen carefully for this one. Can I scroll down? Yeah. So, I'll take my own example here. Xn plus 1 equals 4 plus xn. Now, what's different about this formula compared to the last one? Yeah, firstly, it's not xn equals, it's xn plus 1 equals. What else is different?
There's another.
Yeah, there's another x as well, isn't there? So if I said to you, what is the 4th term, what do you make n equal? 4. And where's the n here? There is no n. So what's happening in this formula... Let me undo. Okay. Right. What's happening in this formula is you get each term piece by piece, okay? They must give you a term to start with in the question. So let's say I have, for example, start with x1 equals 2. So that's given. The way you read this is the nth term, isn't it? So like if this was 7, this would be the 7th term. If it was 8, it would be the 8th term. But this is n plus 1. So this is the nth plus 1 term. In other words, if we just want to keep it nice and simple, the English, this is the next term. And this is the term that we're on, like the present term. So this is how you read this formula. You read it as the next term equals 4 plus the present term. So whatever term you're on, you add 4 to it, and you get the next term. So if I start with x1 equals 2, what is the next term? What would be next?
2 plus 1.
Yeah, so 6. And then what would be next?
10, yeah.
10, yeah. Because the next term is 4 plus whatever term you're at the moment. Okay? So this is not direct. Because if I want to get the 10th term, what do I need to find first? 9th. And then before I find 9th, I need 8. 7, 6, 5, 4, 3, 2, 1. So you can't jump to any term you want. You have to go by it piece by piece by piece. Because the term that you're on lets you calculate what's next. Okay? It's not direct. So there's a word in English that means something that goes back inside of itself. Not invert? And not inception, no. No, so we have some word that means the answer goes back into itself to get the next answer, that there's some kind of loop. No? Recurring, recursive, yeah. That the answer feeds back into itself. So recurring, recursive. So it's not direct sequence, it's a recurrent sequence, a recursive sequence. Now that's a simple example. And I'll give you one just to practice, and then we'll look at more complicated ones. So I have xn plus 1 equals 5 multiply xn. And I tell you to start with 2. So I would like everybody to give me the next 3 terms. The next 3. What are they? Okay, so what's the next term? 10, isn't it? You take the 2, you put it inside, 5 multiply 2, 10. You take the 10, you put it inside, 5 multiply 10, 50. You take the 50, put it inside, 5 multiply 50, 250. And then if I want the next one, you have to repeat. So it keeps going back inside of itself. So this means, we call this recursive. Okay. Let's have a look at a more difficult example. So I'd like people to try this one for me. So this one here is actually 4c. un equals, no, actually, we'll make it f. un equals minus 7 plus 4 over vn minus 1. Now, I know I've changed the notation a little bit here, but that's okay because that happens in the question sometimes. This one, sorry, that's a u, not a v. That is a v here, not a u. This is still the next piece, and this is still the present piece, although I don't write n plus 1 and n. Instead, I write n minus 1 and n. But it's still the same idea, because what number comes after n minus 1? What's after n minus 1? No, that's backwards. It's n. Okay, so it's still the same idea. So if I tell you to start with 8, can you give me the next 3? So I want the next 3. And you can give it to me as a decimal. So give me the next 3. Yeah? For the next one? You might need the calculator now. So it would be minus 7 plus a half, plus 4 over 8. So that should be minus 6.5, is it? Is it? Yes?
Yeah, minus 6.
Yeah, okay, good. So that's minus 6.5. And then you put minus 6.5 in this. Minus 7 plus 4 over minus 6.5. Yep. How's it 8? That's given in the question. You must be given a beginning term, an initial term. So what's next, Naveed?
Minus 7.6.
Minus 7.6. And what's next?
Minus 7.5.
Now, if you're looking at this list of numbers, do you think there's any pattern? Is it doing anything that you can notice? Like, is it getting bigger? Is it getting smaller? Is it staying the same?
Smaller than me.
Yeah, it got smaller. It's kind of moving up and down, isn't it? Do you think it's moving towards a certain number, or do you think it's not? It's just changing its value. In other words, if I keep doing this, do you think it might move to some particular number?
Yes. No.
Yeah, maybe. So what I'll do is, we can have a look in Excel here. We can make a lot of terms. So what's my first term? What did I say it was? 8. And now let me type in my formula. So what's the formula? It's minus 7, yes, plus what? 4 over the last term, which here is this one. So you see you got minus 6.5. And then what's next? Minus 7.6. So that's the first, second, third term. Now, do you see what's happening there? Very quickly, around about the fifth term, it stops really changing, doesn't it? You can see from the fifth term all the way down to the 100th term, it's basically minus 7.53. Like, it stopped changing here because Excel only does so many places of decimal. So there's a word that describes a sequence that does this. What word describes something that is coming together? Oh, you're so close. Someone else maybe said it. Conversion. Yeah. So we say this sequence is a convergent sequence. Converge means it comes together. Okay. In the exam, I've seen it many times. They will ask you to calculate the first 3 or 4 terms, and then they will ask you to decide if it's convergent or not. Now, if I look at my example, if I look at the first 3 terms, I don't know. I wouldn't be so confident to say it's convergent. I think I would need more than 3. I think maybe after the 5th term, what do you think? It looks pretty clear that it's convergent. Sorry, I should also say in the exam they won't tell you exactly how many terms to calculate. They'll just say, calculate the first few terms and then decide if it's convergent or not. And they might not even say calculate. They might just say decide if it's convergent or not. So anyways, my point is, you should try to make 5 terms. 3 isn't really enough. 5 is enough. Okay? So that's convergent. So in question 4, you see number 4 there? In each example, I want you to say if it's convergent or some other type, which we'll look at now. So let's just see here. Yeah. So let's have a look at B. So what's the first term in B? Sorry, for B, what's the first term?
Minus 4.
Minus 4, okay. And what's the formula?
Minus 5.
Minus 5
Minus 7 over.
over the previous term. Minus 3.25. So if I go to the 5th term, no, I see. I don't think so. No, it's not convergent, is it? Because it's jumping around. So, does anyone know the opposite of convergent?
Divergent.
Divergent. Very good. Divergent. So this is divergent. Okay? And then the last type, which I'll do, where is it? For example, for or. So in for or, what's the first term?
Minus 9.
Minus 9. Okay, and then what's the formula for the next term?
Minus 2.
Minus the term, yeah. So you get, sorry, forgot to put in my minus. So you get 9. Now, you probably realize what's going to happen here. Yeah, what's happening each time? It's just
9 minus 9.
9 minus 9. So the physics students might know the word here, but what word describes something that repeats itself? Begins with a P. No? Physics students? No? Maybe periodic? Yeah? Yeah. So periodic describes something that repeats. Okay? So if you look at number 5 at the bottom of the page, you see that's where I say state. Oh, okay, actually, yeah. State whether each sequence is convergent, divergent, or periodic. So this one here, which of the three is it? Convergent, divergent, or periodic? Periodic. Yeah. What about this sequence? 1, 1, 1, 1, 1, 1. What's that? Convergent, divergent, periodic. Yeah. It's not clear, is it? You could say it's periodic because it's repeating. What's repeating? 1. But you could also say it's convergent because it's reached 1 and it's staying at 1. Yeah? And in fact, I think it's right to use both words if you want to. Okay? You can say it's convergent, it's true it's convergent, and you can say it's periodic. So the point I'm making is the words convergent, divergent, and periodic, they're not exclusive. They don't exclude each other. It's not like saying something is hot and something is cold. There are only two things that exclude each other here. You can't have convergent and divergent. That doesn't make sense, right? Because what does convergent mean? It means it's coming together. And what does divergent mean? It's going apart. So you can't describe something as convergent and divergent. But you could say, like my example, it's convergent and it's periodic. But in the exam, you wouldn't get an example like this, okay? What happens in the exam is they give you 3 sequences and they ask you to say which one is convergent, which one is divergent, and which one is periodic. So in the exam, you'll get something like this, 3 sequences, you calculate some terms, and then you have to say the first one convergent, the second one divergent, and the third one periodic. It's a good question in the exam because all you're really doing is what? Just using your calculator, isn't it? There's no special formula. You're just using your calculator. Okay. And just a bit of English here. In number 5, you see that word conjecture. Yeah. What does this verb mean? No. Yeah. Yes. Somewhere between decide and guess, isn't it? Why do you think I didn't say prove or show?
Because you can't spell.
True, but not this reason. Now the reason is, please keep in mind, this isn't really a proof. Why not?
Never ends.
Yeah, but it's not really a proof because all I'm doing is looking at some examples, like the first, second, third, fourth, fifth term. Yeah, it's not a proof. So it's possible, although unlikely, that you see in the last one it's periodic, then maybe after term 101 it suddenly changes. Now we know that's not going to happen. Alright? But it's important that you know that this isn't a proof, okay? You're taking some numbers as an example and you're just, like as you said, almost guessing, almost deciding. Okay? So they should not use the verb prove. That would be inappropriate. They might use the verb show or decide, okay? But they couldn't really use the verb prove. Focus was saying. Okay, let me tell you which ones to try. And I'll just tell you, of all those questions there, number 4 is probably the most important because it's the one I've seen in the exams so many times. Okay? Right, so the ones... I'll keep it easy. Straight down the side.
All of it.
Well, they don't take that long to do. They're just calculator exercises. You know how to use your calculator,
When
right?
you use the table, every calculator.
Yeah. How? I know you.
No, like, is it f of x is
Yeah.
negative 5 minus 1 over x minus 1? Is that it?
No. No, actually, you can't use the calculator. Actually, yeah, that reminds me. You can use your calculator to do this recursive one really, really quickly. Let me show you how to do that. You take out the Casio calculator. So, as an example, we'll do 4b. You see 4b there? All right. Now, please listen carefully and type exactly what I tell you. So, I assume that you've turned it on. Yes. Okay. Good. All right. So, what is the first term in 4b? Minus 4, isn't it? So please type minus 4. Type minus 4. Yeah. And press equal. Yeah? Then press AC. AC, yeah? Yes, yes. Now the screen should be blank. Yeah, right. Now, type in the formula, but type it as follows. Minus 5 minus 7 over A and S. So that's minus 5 minus 7 over, and then press the A and S button, the answer button on the calculator.
This?
Yeah. Can you see that? Yeah? So on your calculator it should have minus 5 minus 7 over A and S. Yeah, now press equals. Yeah, now press equals again. Every time you press equals, it gives you the next term. Now keep pressing equals. Keep hitting equals. Yeah. You see, you're making the sequence.
Minus 13 over 4.
You see?
Wait,
So how long would that take you to do? You know, only about 10 seconds. Okay, so they're not that long to do. Yeah.
the next sequence.
No, this is a graphing
No,
calculator.
it does everything.
Yeah. We'll
It does
look at that.
biology
We'll look
too.
at that in a minute. All right, so you can start them now for a few minutes, and then we'll take a break. Okay, so please do these for a few minutes. All the questions down the side. Okay.
So A and S minus 5 minus 7 over.
Hold on.